Hey guys, I'm Vincent, and in this video, I would like to talk about what do chemical engineers do once they get their bachelor's degree. And there's really two main paths you go. You either go and get a master's or a PhD, or you go into industry. And when we think about, before you even start a chemie program to get that bachelor's degree, why are you going to do it? Like, what are your intentions after getting that degree? Because hopefully your education is, or some of us will see our education as a means to an end. So you're going to college because you want to have a career as an engineer. And what does it mean to have a career as an engineer? And you really have to ask yourself, what do I care about? What kind of things do I want to see myself be doing with my skills that I learned through a chemical engineering program? And if you ask me, after I got my chemical engineering degree, what does a chemical engineer do? Um, so if we're going to stick exclusively to the realm of engineering, it's going to involve a lot of mass balances, energy balances, siting heat exchangers, siting reactors, determining what is the optimal volume and pressure and temperature you want to operate your distillation columns at, what kinds of reactors you're going to want to be using based on the reaction kinetics, what kind of catalysts are your best bet to reduce fouling and have your best yield and selectivity. And these are kind of the very strict chemical engineering discipline fields that you see people go into. And if that is your intent, you're probably better off staying in school a little bit longer and getting a PhD or a master's in chemie before jumping into industry. And that is because if all you have is a bachelor's degree and no other experience to talk about as a chemical engineer, um, people are going to look past your resume when you apply to that position, no matter what school you go to, no matter how prestigious the program is. Uh, what you will find, just like I have found and many of my friends have found the hard way, is that just having that degree in chemie is not enough to, in many cases, even have the word engineer in your title. You're going to probably start out as a research associate or um, maybe a process engineer. And, your first, the nice thing about going to Berkeley is that it really got you used to this environment where you're kind of getting rejected and um, things are really tough all the time. And I would assume other engineering programs are also like this too. I do not mean to belittle any other engineering department. It is a really tough subject, and what you're going to learn as you apply in the real world in the job market is that things are tough. And as much as people on LinkedIn or wherever like to chime in and say like, "Oh, we love hiring chemical engineers. Come here, apply here. I'll love you and I'll hire you." I'd say probably 95% of the time, those people are just, you're not going to get a job there, even if you did follow up with them after you graduated, because, it's, and this is something you'll learn as you go through the professional world. Companies need to have an appearance of growth, and they want to look like this vibrant place where there's abundant opportunities and there's always a spot for someone there. And so people, especially more senior uh, professionals, will project an image of growth. And we are hiring the best and the brightest people. We are always hiring the best and brightest people. And why they do that? Well, the answer is, if you think about the uh, contrapositive to that statement, where we are not growing at all and we're barely holding on, um, who's going to want to work there? No one. So they have to project an image that everyone is welcome here. And if you have an engineering degree, absolutely, we would love to have you here. It's actually a lot harder to get those positions than you would think. So that is my experience. Maybe it's been nicer for other people, but the best thing I did while I was in college was have a part-time job. I worked at a pharmaceutical company in the IT department, which has very little to do with engineering, but I was able to get a job offer uh, right out of school because of my IT background, along with the chemical engineering background. Because The employer, who I probably shouldn't mention because I'll violate NDAs, they really wanted people who had both a technical background in engineering and also a technical background in technology. So these are kind of things that I hope would emphasize why it's so important to have other things to you besides a chemical engineering degree. Look at your other strengths and what are your other selling points, and make sure that you are getting experience and documented evidence that you are a professional in these other areas besides chemical engineering. Because when you're in the real world, no training is ever going to prepare you for what you're going to come up against. And even as rigorous as chemical engineering is, and even the number of equations you're going to come across, um, it's still not enough to really prepare you. Like, you're never going to be taught every last detail that you need to know to be a good chemical engineer. That only comes from experience in industry, and that is something that they really hit home well, in my opinion, in the early upper div courses in chemical engineering at Berkeley. Is that we can sit here and we can tell you this equation, but it's really up to you to have to determine when it is appropriate and what are the risks that you take when you make assumptions. And uh, these are the very important things that you take away. And so in that regard, if you're only doing chemical engineering because of a job and the money that you're going to get from that job, you're choosing the wrong major, and you have the wrong reason for wanting to go to school. That is a valid partial reason to have for wanting to do engineering, because you want to do something that society values, and society does value people who know how to do these things, because we need to make uh, products on large scales. But the most important thing that I will argue that you get from any engineering program, or any college degree for that matter, but specifically engineering, is an ability to solve really technical, challenging, complicated problems. And when I was at UC Berkeley, our finals and midterms and quizzes were very much, you're going to have a really hard time coming to them with an answer. You're almost expected not to have an answer. You're not going to come to them and say, like, 342.1 cubic meters is the ideal reactor volume. Oftentimes the math was so complicated that, this isn't a math test, this is an engineering test. We don't expect you to uh, have a precise answer. We just want to see how you've thought about approaching this problem, and how are you going to follow through with this. So, once you've, so the real purpose of these midterms and finals that you come across, at least at Berkeley, was, did you know how to set up the problem correctly? Did you know what the relevant pieces of information are? Did you make the correct assumptions? Did you justify those assumptions correctly? These are the kinds of things that you really need to get good at. And um, once you're at the point where you know how to write the appropriate mass balance or energy balance, and how to uh, all of these right assumptions you can make based on what you've learned from your problem statements, uh, that is the point at which you're very well suited to at least begin to get more into a chemical engineering field. And it was hard, and the only way you get good at it is by practicing it. So, as much as you can watch my videos or whatever resources, or read the book on how the authors have set up a mass balance, there's no substitute for actually doing it thousands of times, learning the hard way on midterms and finals, when things really matter, that they're going to throw you curveballs that you don't know how to handle. And that is the point. They want to see that you have a deeper understanding of this equation than just, oh, I know how to do the math to solve this. If you give me the numbers, plug and chug is pretty simple. They don't even expect, like, getting the answer right meant very little on all the exams I took. It's mostly about how you set things up, how you justified it, commenting as you're working through a problem. Why is this set up the way it is? These are the really important things. And so, uh, what was my experience like after I graduated? So I was someone who really liked biotech. So I did a concentration in biotechnology with my background as a chemical engineer, and kept working in my pharmaceutical company for a while. Then I tried software development, or coding, and then I am now working at another biotech company where we're designing instruments and developing workflows for our platform. And so there are a lot of chemical engineers there, and having the background as a chemical engineer is important, but am I necessarily using mass and energy balances all the time? Contrary to what probably a chemie professor would tell you, not really. It's mostly the problem solving strategies that you learn where you've got very little information and very limited time, and you need to have something to go with. So in my case, if I'm doing customer support and I've got a scientist on the other line, you know, what, how do you understand this problem statement? What are the relevant pieces of information? Uh, just what steps can we take to troubleshoot this and not waste everyone's time? These are the very important things that I'm applying based on partially what I learned in college as a chemical engineer, which is making the most of your finite resources and time, and doing the best you can with what you have. And that to me is probably, in a nutshell, the ultimate purpose of an engineering program. Any engineering program, you're going to know that the people who come out of it are really good at solving these technical problems, and not even solving, but at least setting them up to the point where, all right, you know how to ask for help, you know where you're weak, you know where you're strong, and what needs to be done to actually fix this if we come across a problem in the real world. And so hopefully this video adds some insight to people who are interested in seeing what is life like after you get a bachelor's in chemical engineering. If you do get a master's or PhD in chemical engineering, you'll be more likely to get positions where you are more heavily involved with designing these chemical processes. In my opinion, when you start to design stuff, this is when you are demonstrating mastery of a concept, and we did a little bit of it at the end of the chemical engineering program at Berkeley. But if a company like Bechtel or some huge engineering firm is going to want to hire an engineer to design a syngas reactor, are they going to turn to some kid that just graduated from college? No, they're going to hire someone with a good few years of experience doing relevant stuff before, and that's going to come from people who have masters or PhDs and maybe some bachelors who have industry experience doing explicitly this stuff. So don't really, it may seem strange to think about it this way, but don't necessarily think about that chemical engineering degree as learning just about chemical engineering, because if all you wanted to do was learn about the chemical engineering content itself, you can just watch my videos, and you could take an English major or an art history major and they would know essentially all the same equations that I know. The real thing that you get out of your chemical engineering program or any engineering program is this ability to, or not ability, but a skill that you've practiced and demonstrated on multiple occasions to take these very complicated problems and then begin to break them down and show how they can be solved and what steps you would take and ultimately arrive at an answer. So yeah, with that being said, I hope you guys find this useful. Let me know if you have any questions, and thanks for watching.